All right, if you're watching this video, this is going to review 6.6, which was how to add and subtract unlike fractions, which are going to end up as an improper fraction, and then you have to change into a mixed number. So it's kind of putting together everything that we've learned so far in Chapter 6, and then putting it into problems to see if you can do everything that you have learned. So basically, you are going to be adding or subtracting. I'm going to skip ahead. Say we have 7/9 plus 2/3. Now, I'm not sure how you add it, but there's two ways to add it. So I like to do it up and down, just like I'm adding like real numbers. It just makes more sense to me. But if you like to add it like this, you can add it like that if you would like to. Okay, maybe pause before each problem and you practice and then check your answers with what I put. All right, 7/9 plus 2/3. Well, automatically I'm like, they have unlike fractions, and I have to make them have like fractions. I know that if I skip count by 3, 3, 6, 9, I'll hit the number 9, so I can change my denominators to be 9. And I get 6 9s. Now I have to add them together. 7 9s plus 6 9s is 13 9s, and automatically I know that this is an improper fraction, so I need to change it into a mixed number. So what I do is I think, well, if I have a pizza that's cut into 9s and I'm trying to take out whole pizzas, I know that 9 9s is a whole. So if I have 13 9s, I can pull out 1 9 9s, but I can't pull out another one because that's 18 9s. So 9 9s, 10, 11, 12, 13. And I have 4 9s left over, and that equals 1 whole and 4 9s. Okay? So my final answer for that, and then I check to see if I can simplify, and I cannot because the factors of 4 and 9, they don't share any common factors. Okay, now I'm going to do another one. Let's do 3/4 plus 3/8. Again, you can write it however you want, and maybe you solve it, and then check. So once again, I'm noticing these have unlike denominators, so I have to make them have like denominators because in fractions, I can only add or subtract with things that are the same size. I know that if I skip count by 4s, 4, 8, I'm going to hit the number 8, so I'm going to change my denominators to be 8s, okay? And now I can add it together. 6 8s plus 3 8s is 9 8s. And once again, that is an improper fraction. In my head, I'm thinking, well, if I have pizza cut into 8s, how many 8s can I pull out for a whole pizza? Well, I know 8 8s is 1, and then I have 1 left over because of 8 8s, and then plus 1 more is 9. Or I could divide it. 8 goes into 9 one time. Remainder of 1. So I have 1 whole, 1 left over out of 8 total things. 1 and 1/8. Okay? Let's do 1/3 plus 5/12. Again, unlike denominators, so I am going to try to find like denominators. If I skip count by 3s, 3, 6, 9, 12. Oh, I hit 12, so I can make my denominators 12. That's times 4, and I get 4 12s. And 4 12s plus 5 12s is 9 12s. That's not improper, but you should be thinking, oh wait, there's something I can do with this problem. And if I'm looking at it, my factors of 9 are 1 and 9, and 3 and 3. And my factors of 12 are 1 and 12, 2 and 6, 3 and 4. And I see that they have a common factor, so I can divide both of these numbers by 3 to get 3/4. Okay? All right, we're going to try some more. Hang on, let me skip ahead. Now we're going to talk about subtraction. Okay? Subtraction is a little bit trickier, but it's still kind of the same thing that you do when you subtract regular numbers and not fractions. So if I do 3 wholes minus 4 9s, again, I'm going to write it up and down. Okay? Now, if I have 3 whole pizzas, I'm picturing 1, 2, 3. Well, if this pizza is cut into 9s, I know that these pizzas are also going to be cut into 9s. So I have options. I can either cut all of these pizzas into 9s, and I know that 9 times 3 whole pizzas, because they're all cut into 9s, is 27 9s. And I'm just making my 3 whole pizzas in an improper fraction, and then I can subtract 27, 26, 25, 24, 23. And then I have an improper that I have to switch and make into a mixed number, and I know that I can pull out 9 9s. I can pull out 1 9 9s. 2 would be 18, so I can pull out 18. And then 19, 20, 21, 22, I have 5 9s left over, and I have 2 and 5 9s. Or, I like this way better, to do a little bit less work. I can remember that I have 4 9s, and I know again that I have 3 pizzas, but instead of cutting all of the pizzas, I really only have to cut 1 pizza, into 9 nines. And the other two I can keep whole. So like just when you're subtracting like 142 minus 78, we can't take a smaller number from a bigger number, so we have to regroup it. We're kind of doing the same thing with fractions where we take 3 wholes, we're cutting one pizza up, so I only have 2 wholes left over, and I have 9 ninths of another one. This equals 3 pizzas. 2 wholes and 9 ninths, that's 3 pizzas. Now I can subtract. 9 ninths minus 4 ninths is 5 ninths. And I just have 2 wholes minus no wholes, and I get 2 and 5 ninths. Okay? We're going to practice, and I want you to pause it, and I want you to try. Let's do 2 minus 3 eighths. 2 wholes minus 3 eighths. Okay? Again, I'm picturing 2 wholes, and I'm trying to take 3 eighths away from it. I know that if my one fraction is eighths, I'm going to be cutting both of my pizzas into eighths. There's 2 ways to do this. I either can take one pizza and cut it into eighths, okay? And then I would have 1 whole and 8 eighths of another one because that equals 2. And I could subtract 8 eighths minus 3 eighths is 5 eighths. And I have 1 whole pizza. Or I could do 2 wholes minus 3 eighths. And I can cut both of them into 8 eighths. And 2 wholes is 16 eighths. And then I could subtract 16 minus 3 is 13 eighths, and then I can make that into an improper fraction. 1 8 eighths is 1 pizza. That's 2 8 eighths. Oh, that doesn't work. That's 16. So I have 1 whole, and then 5 eighths left over, and I end up getting the same answer. But I really think that this way is a lot simpler and maybe leaves less room for error. Okay? All right, let's do another one. Let's do 5 minus 7 eighths. So stop the video and you try these. Okay, again, I know that if this is cut into eighths, I'm going to cut my pizzas into eighths. If I have 5 pizzas, I could cut all of them into eighths, but that seems like a pain. So I'm only going to cut one of them into eighths. Okay? I then have 1, 2, 3, 4 whole pizzas and 8 eighths of another one, and I know that that total is 5. And now I can subtract, and I have 4 and 1 eighth left over. Okay? Let's see. Let's do one with 3, and then 3 minus 8 ninths minus 1/3. All right. 3 wholes minus 8 ninths minus 1/3. Okay, first of all, these 2 fractions right here have different denominators, so my first thing I have to do is make them have like denominators. I know that if I skip count by 3, 3, 6, 9, I can change this to be ninths. So I'm going to do that first. And then I'm thinking about my 3 pizzas. And here's the tricky part. If they're cut into ninths, I know that I can take 1 pizza and cut it into ninths. And I have 2 wholes and I have 9 ninths left over. The thing is, though, when I start to subtract, I'm like, oh, 9 minus 8 is 1, and then 1 minus 3 is, I can't do that. That doesn't work. 9 ninths, I can't take away because together, this right here is 8, 9. This is 11 ninths that I'm trying to take away from 9 ninths. I can't subtract 11 from 9. So then what I'm going to do is, it's okay. I'm just going to go back to my picture of 2. And if I made one of these 9 ninths, I'm actually going to make another one 9 ninths and then keep this whole. So instead of 2 and 9 ninths, I'm actually going to have 1 whole pizza and then 18 ninths, because these 2 together equals 18 ninths, and now I can subtract. 18 ninths minus 8 ninths is 10 ninths. 10 ninths minus 3 ninths is 7 ninths, and I have my 1 whole pizza left. Okay? I'm going to leave you, if you want to practice, with a couple problems. You can try, maybe try subtraction, because they're a little bit trickier. And if you need any help, come in and ask, but hopefully this has helped you understand how to add and subtract and then change from an improper to a mixed. All right, bye guys.